application problem for section 3.2. And I want you to look at this. We got this big cola company estimates that total sales, now TS of D. This is a case where the output, the function name, is actually 2 letters. Now, there's nothing sacred about having F of X or whatever. In this case, it's TS, TS standing for total sales. So right now, let's just make sure we understand that when we have TS of D, this represents input or output. Again? Output, yes. Okay. When spending D million dollars, D million dollars, input or output? Input, yeah. So just making sure we understand the problem here. And again, understanding that we have D million. That means if the answer, if we put in a 5, we're not putting in actually $5. We're putting in actually 5 million. Some of you on some of the problems that show up on the WebAssign, you have, it asks for answers based on the work you have, and I've noticed a few of you might put in something like 5, when actually it is defined in a different way. So you need to be sure you read this, and if you have a problem that's asking how much money should the company invest in advertising, you put down 5, you're saying $5, you'd actually have to put down 5 million, because they're asking you a specific answer in a verbal sense, not just what does D, what value D has. But D is whatever we put down for D, we're talking 5 million, not just 5. Okay, so taking a look at this, we have TS of D, and we have this function. Now, this function, let's just talk about it for a moment, because it comes up and we need to know this information. That's a polynomial function. Recognize that it's polynomial? Okay. And then we need to go through and say, okay, what is the degree of this polynomial function? The highest exponent tells us, yes, so it's degree 3. And then if we're looking at, let me just say y equals, let's start with y equals x. And we look at a function such as this, okay, and I put on this this axis the equation y equals x. We need to think in these terms. If I use the most negative value for an input that I can, and I let the input go from that most negative I can think of to the most positive I can think of, which quadrant do we first begin to see output values in? I'll just remind you, they count by 1, 2, 3, and 4. So if I start with the most negative input, I'm going to begin to see the graph in which quadrant? And 3. And if I go to the most positive, I'm going to see it leaving my view on this coordinate plane through which quadrant? Yeah, so we have what we call entering and leaving through opposite quadrants. So if I put that line there, I would have through the first and, or excuse me, in the third and out through the first. Now, let's just change this a little bit. I'm going to change this to be, well, let's say y cubed, or excuse me, x cubed. If I change that to be x cubed, now the same question, if I think of the most negative input and I go to the most positive input, where do I begin to see the graph in which quadrant? Do I begin to see it? In 3, and I would see it leave my view out of which quadrant? 1 again. So it would look something maybe like this. Okay? Now that's going to be consistent for all of the polynomial functions that have an odd degree to them. If it were an even degree, it would enter and leave through what we call adjacent quadrants. and whether that's 2 and 1 or 3 and 4. Now this one I said enters through 3 and leaves through 1. These are called opposite quadrants. But now we've got this negative leading coefficient, so how does that change? Whoops, how does that change what I see here? If it's got a negative leading coefficient, does it in there lead through the same quadrants? Or does it have a different path that it takes? And this someone from this table. It enters and leaves through what? Yeah, and it leaves through the fourth. So it's just like a reflection happening around that. Okay, now we need to understand that so that when we look at this later on, we need to understand the path and where it's going after we no longer see it on the coordinate plane. Okay, just a little bit of review from your pre-calculus work. Okay, so there we've got this. Now the first question is here. Determine the marginal revenue of spending $5 million on advertising and interpret the results. Determine the marginal revenue. What's that got to do with total sales? Up here we said total sales. Now we're talking revenue. Have I changed the problem on you? David's shaking his head no, because they're one and the same. One and the same. Okay, so if that was not something that you were thinking about, now we can talk. Revenue is the same as total sales. Okay, now I realize that I have up here, I have that the function we're going to evaluate with the inputs from 10 to 25, but I want to talk about 5 million just for a moment. Okay, so determine the marginal revenue. Now this is not saying the revenue, this is saying marginal revenue. So what's that got to do with calculus? Marginal revenue. You're in groups. You're in teams now in the company, so use the groups there and come up with an answer. Okay, what's marginal revenue got to have to do with calculus? To determine marginal revenue, we need to analytically do what? Take the derivative. Okay, so we're going to take the derivative. Yes?
If you're going to write it like dy over dx, but it's not, would it be dx?
Yeah, if you were going to write it that, yeah, you'd have the derivative with respect to, and this would be a little weird because we're using the same d there, yeah, and this would then be of ts, yeah. It would be a little unusual.
Okay, but that's true.
But that would have to be, yeah. Don't write it that way.
Yeah, no.
That's why we have multiple ways of writing it, so that the ease of writing it can be can help us out. So go through with your groups and determine the marginal revenue of spending $5 million on advertising. And then the most important part of this whole problem here isn't really just crunching those numbers, it's interpreting the results. I'm going to give you a few minutes. I want you to talk in your groups and be prepared to answer this question. See what you've got so far. The table here, what'd you come up with for your derivative? Okay. Okay. And when you evaluated then that at 5, what did you come up with? Negative 450. Okay, take your inspires. And I'm going to add a calculator. I'm going to go into menu and actions and do, I'm going to define. Okay, so I'm going to define f1 of x, and I'm going to define that to be the original function. So you can look at your handout if you've got it in front of you. Negative 2x cubed, you're going to have to put it in x terms since I'm going to be graphing this then. Plus 90x squared. So everyone needs to be doing this so you can kind of work along with me later. 1200x plus 10,000. And now I'm going to do something else. I'm going to define f2 of x to be the derivative of f1 of x. So define f2 of x. I'm going to go to menu, go to calculus, go to derivative, and I'll just put in x, and I'll put in f1 of x. Let it do it for me here. If I want to see what that is, f2 of x, we'll see what that value is. I'll just type f2 of x, and it will show me. Now, everyone in here can do that on your own, so I'm not too concerned about that. But just thought I'd show that to you so that for future use, you can maybe use that in on your quizzes and tests. Okay, now f2 of 5, we had an answer of negative 450. Okay, you could do it on your own. I mean, it doesn't take that much arithmetic to do, but that's the value. Okay, let's do, I'm going to add a graph page, so whatever way you can, add a graph page. And we're going to graph, of course, the total sales. So that means the original function. This is another common error I'm seeing on the quizzes and tests, is that we're confused on which function to graph. You're always going to graph the original function. Okay? Just kind of tuck that away. You're always going to graph the original function. Now, when I press enter, I don't see this at all. But remember, you've got some numbers out there that are going to be a little bit large, and I don't always do this, but I'm going to now. Go to menu, go to window, zoom, and there's this thing down here at A called zoom fit. This is one of the things you can use. If you don't know where to find the graph, just use a zoom fit. And I don't like the window, so now I can change it. But I have a general idea of where that window is. So I'm going to go back in the menu, go to window settings, and I'll see now that it's about, okay, I don't really need negative 12. I'm going to make it negative 1. And I remember now in the problem, it said evaluate this for money, advertising money between 10 million and 25, between 10 and 25. So I'm going to make this, I'm going to make it at least 25. And I'll scale by 1. Now my minimum, I really am not interested in too much of a minimum revenue, total sales, but I will make it negative, let's make it negative 1,000. And I should have called your attention to the fact that right now it says 35,800, but take a look, that's for this piece up here. And where it actually crosses, I can't really move it too far out of the way, is much farther, much closer, and I know this from the last class, so trust me on this. I'm going to put in 15,000, and I think I'll scale by 1,000. Now, if that's not right, we can always go back and change it. But this should give us a fairly decent window to work with. Okay, fairly decent. Not perfect, but fairly decent. I'm going to move that up out of the way. Now, graphically, to show me what you just found for investing $5 million in advertising, now wrap your mind around this as a business person. You're going to spend $5 million in advertising. For that $5 million, you want to make sure that this company gets their money's worth, right? Okay, so let's go to menu. Let's put a point on. You guys are really good at this now. Put a point on. And through that point, in order to show the derivative, you probably don't even need me to tell you. A derivative is a slope of a line. What line? A tangent line. Okay, so of course I need to draw a tangent. So I go back into menu. You guys know where to find that. Menu, points and lines. And I'll just draw a tangent there. And you know that the important part of that tangent isn't just that it's a tangent, but it's the derivative that tells us it's the, so measure the slope. It's the slope of the tangent, so measure the slope. Now, nothing really shows where I need this to be because I'm not at the point I want to be. So, again, you guys know how to change that. Go in, double click on that, change it to a 5. You know how to identify this. I'll make it slope tangent equal so we don't lose track of what that value is. One last thing I want to do is down here where the output value, you know, this output value tells me what? Yeah.
Use your order pair. How beautiful.
Tell you that in just a moment. Answer my question here and then I'll do that. What does the output value of this point tell us? It's on the original curve. What's the original curve a function of? Total sales. So the output value, that tells me how much total sales I have when I invest $5 million in advertising. I don't like the fact that it's in scientific notation. Notice that I've got it hovered. I'm hovering over it, and then just press the plus key, and it's going to expand the number of digits. So for $5 million in total sales, I'm sorry, $5 million in what I'm trying to say here, in advertising, it actually doesn't say that total sales is in millions also, but I'm going to assume that it's not just $6,000. How about that? You agree with me on that? That's not too good of a return if that's the case. So we'll assume that it's more than just $6,000. It should have been written in the problem, but we'll assume that. Okay, now, Jordan, you've lost your ordered pair? I knew you could do that. I knew that. Okay, so now, the most important part of this is not that, okay, I'm showing you the derivative, but what does it mean? Did you get to that part in your discussion? What does this slope, this derivative, this marginal revenue mean to our company? I'm going to give you 2 seconds to focus on that. Let's see what kind of answers we have. This table, Morgan, you were...
We talked about that it was, since it's negative slope, the amount of revenue that you're bringing in is decreasing.
Okay.
Not that it's zero, but that
Okay.
it's not.
But what does the negative 450 mean? Because I can see that, you know, I'm on a downhill because all those tangents are going downhill. But what does that negative 450 mean? Yeah, Nicole.
And at that point, we are using
So it means that you're losing that much revenue.
decreasing that.
Okay, okay. Now, here's what I want you to do. It's decreasing that much. Let's go to your calculator page. Let's put in F1 of 5. Remember, this is now calculating the amount of total sales for $5 million in advertising. And we have $6,000 million. I don't know if that's whatever that is. Yeah. Let's just assume this is a good company here. Okay, now let's put in F1 of, because what we're saying is that if we spend one more unit, what's our unit? $1 or $1 million. Okay, if we spend $1 million more, one more units, that may make it 6. Our total sales should do what? Should do what? It should go down by about 450. Okay, so let's see. Did it go down by about 450 million? Yes. Okay, so that's what that derivative value means. It doesn't mean that the revenue is negative anymore, but as Nicole said, it's the, we're losing money because we're spending $1 million, but we're not getting as much for our investment here. Okay, now let's go back. We're actually, though, not looking at 5. The problem is actually saying between 10 and 25 million, 10 million and 25 million. Now, why would we be looking at between 10 million and 25 million? What would be significant about that? Again, Nicole?
Because of this like increase in
Yeah, and I don't like the window I have. I'm going to change it just a little bit. I'm going to make that input to be, let's say 27. I don't like to stop right at 25. So make it 27 there. There we go. Yeah, between 10 and 25, we've got, now if you look at the graph between input 10 and input 25, the graph has 2 points, and this is what Nicole's talking about, 2 points where it changes direction, okay? Changes direction in 2 places, so it's kind of an interesting amount to talk about. Okay, so if we are looking at $10 million, we're right about here, and it says it's a minimum there, okay? Now, let's talk a little more about the interpretation piece. When I'm at 10.3 million, 10.3, the input represents what again in the problem? $1 million of what? Advertising, okay. And as I move that point, if I'm at $13.5 million in advertising, what does that 136 represent? Okay, so revenue will increase by $136 million. Yeah. Imagine that. Now let me go back here. This is pretty amazing. I'm going to go back here to about 10. When I'm back here at 10, and I look at that, I'm going to take it out of scientific there. When I'm back here at $10 million I'm spending. So, okay, imagine you're the company, you're the person who they're looking to help them know how much advertising money to spend. How much money to spend on advertising. If the company spends $10 million in advertising, what is their return going to be on that $10 million if they spend one more, if they spend $11 million? What's their return going to be? How much more will they get in total sales if they spend $1 million? Yeah, not a whole lot. Almost, in fact, if we're at the true minimum, they should be getting nothing more. Could you honestly tell the company to spend $11 million if they're not going to get any more in revenue? Why? If I can spend $10 million in revenue and get the same amount in revenue as spending $11 million, why spend $11 million? But look what happens. If I move this to about 12, if they spend $12 million, what happens to revenue? You spend one more million, you get how much? About 100 million more in revenue. Okay, that sounds pretty good. Let's go to about 14. Now, if I'm already spending $14 million and I spend $1 more million, the company's going to get how much more in total sales? About 140. That's a pretty easy conversation to have with the company, isn't it? Hey, listen, you invest $1 more million in advertising and the company is going to see an increase in revenue of about $142 million. Not bad. Not bad return. Okay, but let's see. Whoa. Now, if we're spending $15.5 million in advertising, if you spend $16.5 million, you're going to get even more revenue. Okay? Pretty easy sell. Continue. Uh-oh. Now what's happening? Now if I tell the company, hey, if you're going to spend $16.5 million, total revenue is now, is it still increasing? But what's the difference between that and 15? Tell them again. Yeah, the revenue is still going up, isn't it? Look at that. The revenue is still going up, but the rate of return for that $1 million investment isn't as great as it was before. Okay? What happens if I continue? Could you tell this company to spend $20 million in advertising? Pardon? You could, yeah. But what's going to happen if you go past 20 million? Now, revenue begins to decrease and the amount of return for that extra million actually is going to lose money in total sales. Okay, now, we see this visually. Okay, we see it visually. There's a couple of things, and again, I'm combining about 3 sections here in our discussion this morning. What I want you to focus on is this. There's a turning point right here, and at a turning point, when you get to the turning point where it actually says maximum or minimum, what does that mean about the derivative? When you get to the turning point, what does that mean about the derivative? Say it again, Albert. Yeah, the derivative is 0, which means that for each additional $1 million we spend, we're not going to be getting any more in total sales. Okay, how do we find that analytically? Okay, now, work in your groups. How do you find this analytically, those turning points? Okay, let's see what we've got here. The question I'm asking is that if we are looking at the curve, we can see that we've got 2 turning points. Visually, we can see this. I want to know analytically how we know that. And so if we're looking at the derivative, how does the derivative help us determine where those turning points are located? Now, on one side of the turning point over here, the function is decreasing. This is section 3.1. Okay, this function is decreasing on this side, and then it increases on this side. Okay, if I put a tangent over here, the tangent over here is always going to have a negative value. If I put the tangent on this side, it's always going to have a positive value. So at the turning point, the tangent should have what value? 0. So if this all goes back to our definition of a derivative, that our derivative is the, hang on a second, let me make sure this is going here. There we go. Okay, the derivative is the slope of the line tangent to the curve. If I've got a positive, if I have a positive curve, and then I have a negative and then a positive, you can't go from negative numbers to positive numbers without passing through the value of 0. It's called the intermediate value theorem. So, analytically, what do we do with our derivative? Courtney, what do we do with our derivative to find those turning points? We set the derivative equal to what? Yeah, because a 0 derivative means that we have a line that has a 0 slope, and a 0 slope is a horizontal, and that's what happens at our turning points. Okay, so we're going to set that equal to our derivative. How am I going to go about solving that equation? Trilogy, what do you have there? How am I going to solve that? Okay, factor out a negative 6. That gives me d squared minus 30, d plus 200. Okay, and then what? Okay, and then factor. Okay, and I get d minus 10 and d minus 20. Okay, so now we end up with the fact that if this is product equals 0, that d has a value of 10, or, because we can't have two values of the input at the same time, or d is equal to 20. What happened to the negative 6? Well, it's a factor, but it can never be 0 because its value is negative 6. Okay, so we go back now to our graph, and we set then the input at 10. We get a slope of 0. And if I set that to be 20, I get another slope that's 0. Okay, so I do now know where my turning points are. Okay, now I have to say that these are possible turning points, because there are some graphs where we can find those 0 slope tangent lines, and they're not turning points. We want to make sure we say possible turning points. Okay, let's look at this. More importantly than knowing where these turning points are is knowing, remember this thing here, that we had our slope of that line. The derivative is increasing, which means that for each additional $1 million of investment, the revenue is going up about $60 million. And over here, for each million, if I'm at 12.8 million in advertising, each additional million's 121, and so forth. And there's a point in here, though, where it stops increasing and starts to decrease. I need to know, now listen carefully to the words I choose here. I need to know where the return of my investment begins to diminish the increase in total sales. Okay? What is that input value where the return on my investment, advertising, begins to diminish total sales revenue? It's called the point of diminishing returns. The point of diminishing returns. Okay, at what point does my investment bring me less return? The returns begin to diminish. Okay, now in order to do that, we need to talk a little bit more about some stuff. So I'm going to move this back so we're not looking at that. And I want to, let's go in here. Okay, so there's our graph. Now, let me help you focus on this just a little bit. If I bring the shade over to about there, we've got a couple of terms I wanted to introduce to you. You might have heard these before, and I know you have intuitively you have the concept. If I'm looking at this portion of the curve, the terms are concave up and concave down. Would you say that the graph is concave up? Now, when I think of concave up, I often use the imagery of coffee cup up. Okay, so is that portion of the curve concave up? And if I continue to move this through, would we continue to say that the curve appears to be concave up? Now, think about the imagery of the coffee cup. If the coffee cup is up, that's a positive thing because coffee stays in the cup. Okay. But if I have a concave up, there is a point at which it's a minimum output on that. Okay, so if it's concave up, that's a positive because the coffee stays in the cup. Concave up, but you get a minimum, which is kind of a negative idea. So focus on the fact that it's concave up, coffee cup up. Okay, now I'm going to mark, now let's see here. Let's do this first. I'm going to mark right about here. Okay, something along that line. Okay, and I'm going to pull the shade now from the other direction. Would you agree that it appears to be concave down? And it continues to appear to be concave down until I get to somewhere where I marked it before. Okay, now if it's concave down, coffee cup down, that's a negative because the coffee comes out of the cup and all that stuff. That's a negative. So think about concave down being a negative idea. However, when it's concave down, you have a maximum output when it's concave down. Okay, so those two terms are going to be really important to us, concave up and concave down. So if we use, think of those ideas. I want to know more about this whole idea of concave up and concave down. And then we're going to talk about that point where it changes concavity. So before we get into that, let's introduce the idea that we had a function, okay, and we took its derivative. A derivative is a function, agreed? So you can take its derivative. We're going to take the derivative of the derivative. Just think of it as another function. So I'm going to come down here, and I'm going to write again that derivative. And let's see, that was what? Negative 6d squared plus 180d minus 1200. And if I take the derivative of the derivative, we call that the second derivative, and we put 2 prime marks up there. If I took the third derivative, I'd have 3 prime marks, and then we start getting into our Roman numerals here. But take the derivative of the derivative. Okay? The derivative of the function, the first derivative, negative 12d, That's 180. Okay. Now, what I'd like you to do, we determined that we have a turning point down here at 10, and then another one over here at 20. So let's look at the second derivative at 10. Second derivative at 10. Now again, remember, I'm not just staying with 3.2 now. We've got like 3.3 in here and maybe even some 3.4 sections in here. If I put 10 in there, what do I have? And you know, I really don't care what the value is. What I care about is the sign of it. Is it positive or is it negative? Positive or negative? Positive, yeah. Negative 120 plus 180 is a positive, positive 60, okay? If it's positive, what did we say happens at 10? Is it concave up or concave down? Concave up. There's that positive idea that if we look at the second derivative at 10, we are looking at a positive quantity. Therefore, the function is concave up and at d equaling 10, the outcome is a what? Minimum or maximum? It's a minimum. Okay? Is a minimum. So we went up here and we said, okay, that was a possible turning point. When we actually put that 10 into the second derivative, we see that it's positive, it's concave up. So in fact, it in fact is a turn. It's not a possible now, it's a definite. It is a definite turning point, and it's a minimum. Now, what we have up here, the work we did up here is known as the first derivative test. This is what you read about and watched in section 3.2. What we're looking at down here is known as the second derivative test, because we're using the second derivative to evaluate and determine some things about the original function. Okay, what happens at 20? So go ahead and put 20 in. Again, I don't care what the value is, but I care what the sign is. Turns out to be positive or negative? Negative. Yeah, negative 220, or excuse me, negative 240 plus 180 is negative. So therefore, what conclusion would you write for that? Therefore, yep. Yep, is a maximum, yep. Doesn't look like down, we'll make it look like down. And at d equaling 20, the outcome is, now I should really say relative maximum. Just like up here, I should really say relative minimum. Let's talk about that just for a moment. Why is the word relative more appropriate than, and the other one is absolute? Okay, Y is relative. If I'm looking at 10, if I move this point, and I get it right there at the minimum at 10, again, remember, the input is how much money I am spending on advertising. I'm spending $10 million in advertising. The total sales is $5,000 million. Okay? Why can't I say that is absolute minimum? And here's where we go back to where we started the lesson. What kind of a function do we have here? Megan, help us out.
With the relative part?
What kind of a function do we have here? I'll ask you just certain little questions. You can just answer those, okay? Polynomial of degree what? 3. And what is the overall shape of that polynomial degree 3 function? It enters through which quadrant and leaves through? Okay, because it's got a negative leading coefficient, yeah, it's going to enter through the second and leave through the fourth. If I look at that function, let me go back up here so I can draw on it. If I look at this function and I realize that this thing's going to continue on, is there a point where the outcome is less than 5,000? Yes. All we're talking about, though, is in this little bit of a neighborhood, this area of $10 million being invested in advertising. In that neighborhood, in that amount, the revenue, the total sales is 5,000. Okay, but I can't speak for forever, because once it leaves my view, it's going to continue to go down. How do I know that? Because it's a cubic polynomial function. Okay, same thing about the maximum. Is that an absolute maximum? No, because the same thing over here, we can see that it has other higher, greater outcome values than what we have over here. So we can only speak about this in a closed-in little, we call it neighborhood of that. Okay, so if we look at those possible turning points, we find out that at 10, the second derivative is positive, and at 20, the second derivative is negative, which means, again, that it's concave up, and then it becomes concave down. So now the question is, what's that magic point where it changes concavity? I'm going to pause this and let you think about that as a group. So here we go. Analytically, how do you find that? We call that, again, the point of diminishing. Oops, can't spell diminishing today. Diminishing. I always figure if I scribble you can't read it, then it's okay. Returns. Okay, point of diminishing return. How do you find that point? Nicole, help us out. What did you guys talk about?
We took the second derivative and made it equal to 0.
Okay. And the reason you made it equal to 0 was because, whoops, because, okay. And to get from positive to negative, you have to go through 0. So yes. Okay, so if I make that, let's see, it was negative 12d, the negative there we go, plus 18, or 180 rather, you found that d has a value of 15. So when you spend $15 million for advertising, should the company spend more than $15 million? Should the company spend, this is what the company has hired you for, okay? The company has hired you to tell them how much money, because your team is in charge of advertising. You go in and you try to convince the CEO of how much to spend for advertising. And you tell them, if you spend $15 million, what? Jordan, again?
What's the most that you would want to spend?
Because?
If you go any higher than 15, revenue will still be increasing, but it's increasing at a decreasing rate.
Yeah. So we're going to get the most return for our advertising dollars if we spend $15 million. We can spend more. Okay. So you and your team have gone on the line, and you have said to them, $15 million is the magic number. Based on what research has said about advertising in our company with total sales. And so if all of the people involved in this process, so all the salespeople, all the bottlers, if you're at a cola company, isn't it? Yeah, cola company. All the bottlers, all the workers in the in the factory, all of the delivery people, all of the secretaries, all of the people, if everyone does their job right, the company is going to gain the most they can for each additional dollar. They're going to gain the most at that point. And you will come out being the shining star of that company. And you will rise to the top. And you will be the CEO. And when you're at the CEO of this wonderful company making all this money, you're going to have an interview someday. And they're going to ask you questions, and you're going to say, and I owe it all to my college business calculus teacher. Okay? Because of that class, I knew the answer, and that's why I was able to bring the company that much money. Okay, now I told you who my famous person is. I have a claim to fame. Have I told you? You guys are too young to know him, but he's 40 years old now. But Luke Perry, the actor, I often think of Dylan because he played Dylan on Beverly Hills 90210. Okay, I talked with him a few years ago. And I said, and when I talk about him and I do all this work, I often say, and I wait for the day when in an interview, he says, I owe it all to my high school algebra teacher. So when you become that CEO of this huge company, you're going to give an interview. You're going to owe it all. Make sure you know my name. Okay, how to spell it. Okay, anyway, now, between now and the end of the term, I'll probably give you at least one, maybe two quizzes, okay? The only test you're going to have, though, from now, you're only going to have two tests. It's going to be the one given on Thursday, May 5th. That's the very last day of classes before finals. And we're not going to be able to meet finals week because I have to be on a trip. So that's going to be the last thing. And if I gave you any one question, I would like to give you a question like we were discussing today. And you are that person in the company responsible to advise the CEO of how much money to spend. And whether or not you pass this class would be whether or not you gave the right answer to the company to make the most money. That'd be fair, wouldn't it? Okay. So as you work on these problems, be sure that you can answer all the questions. I will put all of this on